Linear algebra. Now, why this linear algebra is given so much importance, and what is this linear algebra? Okay, so linear algebra has to deal with the study of linear equations. It is basically linear algebra deals with the methods of solving linear equations. All right, now linear equations, as we know, are of this type. Say simple, a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. So this we know is one of the simplest forms of linear equations, and then we need to solve for x, y, and z. All right, we solve like this. This is linear equations. Now, how do we use this in engineering? Our most of the engineering problems, when other than the simple ones, the complex engineering problems has to go for numerical methods of analysis. All right, and numerical methods of analysis, and in those numerical methods and analysis, you have to deal with matrices and linear equations. Very interestingly, even your differential equation, your partial differential equation, for example, suppose you have a partial differential equation, okay, of some function, all right, like this. Now, both for linear differential equation and partial differential equations, the way to solve in a real life situation is to convert this by approximations to this form, to linear equations form. All right, and then you solve the problem. So when I was studying matrices when I was young in in high school, I used to wonder why matrices we have to study. What is this? Generally we do addition and multiplication of numbers, but why is that matrix multiplication is defined in a strange way? I never meaning I used to wonder, but I didn't understand what it is. Okay, so this matrix multiplication we know is 2 into 2 4 plus 3 7, and this is 0 into 0 plus 6 6. So we multiply the row with the column elements. So I wondered why this is so, and the answer lies later is in solving differential equation, solving linear equations. I'm sorry. In this linear equation, you see here, this linear equation can be written in matrix form. and then you can solve this. This linear equation can be written in matrix form like this, and then you can solve for this matrix by solve for x, y, z by various methods that we'll discuss soon. There'll be so many methods. See, we can do hand calculation if it was two unknowns. Simple hand calculation we can do. Just for three unknowns x, y, and z, the calculation becomes tedious. Then what to speak of if there are 10 unknowns to deal with in a linear equation? Whereas, uh, by matrix methods, we can solve very, very easily. All right. And I was using those who are in electrical, electronics, and civil and mechanical, you may have heard of finite element softwares. Okay. ANSYS, Abacus. You must have heard about these softwares, NISA, Nastran, and some of you must be working on it for your final year projects and so on. Now, these are finite element softwares. The background of solving is your matrix methods. When I was doing my master's, that was between 98 and 99. When I was doing my master's, I was using Abacus and ANSYS. That time, the maximum size that these softwares could handle, a matrix size, was 99,000 by 99,000. All right. After that, it was like, oh, you have to simplify your way you give your input. Otherwise, 99,000 by 99,000. This was the size. But now it is unlimited. Now with the computing facilities, we have unlimited. So the basic matrix methods that you are doing now, you will have to use them at a higher level of study. All right. If you are going to deal with finite element modules, or uh, flexibility or displacement methods of analysis, and see, whenever you have a differential equation, you can convert it this way and solve. In my masters, my whole masters project was to do matrix solving only, and I had to write code. I had to prepare code, programming, using a programming language. I had to solve a matrix problem only. So what the basics that we study here has tremendous impact in your understanding of engineering. So although one may think, what this matrix is something very simple, but later on you will know how powerful these tools are. Okay, the linear algebra. That's why in all higher engineering mathematics also, linear algebra is discussed. So that was the background. Now we start with the basics, and we build on this subject. So in GATE and IES, the concepts they ask in linear algebra, all right, the concepts that are asked primarily are rank of a matrix, okay, then solution types for linear equations, whether the linear equations have infinite roots or infinite solutions or finite solutions, so on. Very important, they ask for eigenvalues and eigenvectors. All right. These are the three things that prominent. If you take 70 questions, or 100 questions, around 75 questions will be on these, and remaining 25 questions will be on some properties of matrices and determinants, directly or indirectly. However, the main focus is on these.